Hello, and welcome to Investigative Math. Today, we'll be going over the 2019-2020 Number Sense Test 1, problems 1 through 10. So let's get to it. Keep in mind, every trick used in this video will be explained in more detail in videos that I've linked in the description. So, for our first question, we have 2020 plus 2022 plus 2024 plus 2026. Here, let me zoom in just a little bit. Okay, so you may notice something, and that's that we have a sequence here where the number next is 2 more than the number previous. So what that means basically is to get from 2020 to 2022, that's adding 2. 2022 to 2024, that's also adding 2. And the same thing for 2024 to 2026. When you have a sequence like this, where to get the next number you add a constant, this is called an arithmetic sequence. Arithmetic sequence. And whenever you have numbers or terms in an arithmetic sequence being added together, we can use a trick. Now, you have 2 options for this kind, because you're adding an even amount of numbers. What you can do is either you can take the median or the middle value term, the median, and multiply by the number of terms, or you can add the middle 2 numbers and multiply that by half the number of terms. So personally, I think that our first option is easier, but I will show you both ways. So to find the median, you just have to find whatever number's in the middle here. So halfway in between 2022 and 2024, our median is going to be 2023. And we have 4 terms. And so the sum is going to be 2023 multiplied by 4, which is 8,092. Now, the other way you can do this is to add the middle 2 terms. So 2022 plus 2024 is 4,046. And then once you have that, you can multiply by half the number of terms, or 2. There are 4 terms, so half of that is 2. And you can see 4,046 multiplied by 2 is going to give you the same answer, 8,092. Okay, to recap, when you have an arithmetic sequence, or a sequence where to get the next term you add a constant number, you can A, take the median of your sequence, in this case 2023, and multiply by the number of terms, or you can take the sum of the middle 2 terms and then multiply by half the number of terms. So 2022 plus 2024 gives you 4046, multiplied by half the number of terms, or half of 4, which is 2, gives you 8,092. Okay, for our second question, we have 19 times 14. So an easy way to do this is to realize that this is the same thing as 20 times 14, but with 1 fewer 14, because it's 19 times 14. So 20 times 14, you can do 2 times 14 and then multiply by 10. So that gives you 280. Subtracting 14 gives you 266. And so 19 times 14 is 266. So for our next question, number 3, we have 16 plus 18 minus 11 plus 12. Now you can probably just do this working left to right, but I'm going to try to show you a faster way. So what you can do is pair this minus 11 and this plus 12, and that's going to give you a net plus 1. So whatever you get over here, basically what I'm saying is whatever you get over here, if you subtract 11 and then add 12, is going to be the effect of having this part, the 16 plus 18, and then adding the 1. 16 plus 18 is 34, plus our 1 is 35. Basically, it just allows you to work with simpler numbers. All right, for our next question, number 4, we have 637 divided by 7. So we can basically just divide this as normal. So I'm going to set up a long division problem so it's easier to visualize. So 7 does not go into 6, but 7 does go into 63, 9 times. So with that, we subtract 7 times 9, and that's a remainder of 0. We bring down the 7. 7 goes into 7 one time, so we get 91. 637 divided by 7 gives you 91. Okay, so to recap, basically just divide this as normal. 63, 7 goes into 63 9 times, 7 goes into 7 one time, so all we have is 91. Okay, for our next question, didn't we do that? Okay, for our next question, we have 95 times 25. So we can use the 25's trick, and the concept behind the 25's trick is this. So I'm going to give an example. Say we had 16 times 25. Well, we can equate 25 to be the same thing as 100 divided by 4. So whenever we do this, we can just divide 16 by 4, because think about the commutative property of multiplication. Commutative property of multiplication basically says that 3 times 2 is the same thing as 2 times 3. You can flip numbers around in your multiplication. So we can basically say that this is the same thing as 16 over 4 times 100. 16 over 4 is 4 times 100 gives us 400. And we can use the same kind of logic to figure out number 5. If we just divide 95 by 4, well, that doesn't go in evenly. So maybe we'll think about rounding it down to a number that does go in evenly, like 92. If we divide 92 by 4, you get 23. But before you write your 2 zeros, because this isn't 2300, we still have 3 extra 25s. We calculated 92 times 25, but what we want is 95 times 25. So we have 3 extra 25s, and so we just add that. 3 times 25 is 75, so we just add that to our 2300. To recap, basically what I did is I separated this 95 into 92 and 3. And then multiplied that by 25. We know 25 times 92 is 2300, because we can just divide 92 by 4 and multiply by 100, which is the same thing as 25, since 25 is 100 divided by 4. Then, using the distributive property, multiply 25 by 3, which gives us 75, and then 2300 plus 75 gives us 2375. Okay, for number 6, we have to convert a percent to a fraction. Now, the easiest way for me to do this is just convert it to a fraction. We know 48% is just 48 out of 100, right? And then just simplify this fraction. First thing I notice is a common factor of 4. Divide 48 by 4, you get 12. Divide 100 by 4, you get 25. And can we simplify this anymore? No, because 25 is 5 squared, and so its only factors are powers of 5. And 12 doesn't have any factors of 5. So this is our final answer, 12 over 25. To recap, all I did was I turned this percentage into a fraction, making that 48 over 100. Why did it do that? We got 48 over 100, and then I just simplified the fraction. So I know 4 goes into both of those. So once I divide numerator and denominator by 4, I get 12 divided by 25. 12 and 25 don't share any common factors except for 1, and so I know my fraction is simplified. Okay, for number 7, we're asked to find the remainder of 21,347 divided by 11. Okay, this may seem rather daunting, but like most things on this test, we do have strategies. We do have tricks for solving these. So what you want to do is start on the right with our 7. So do 7 and then alternate between subtracting and adding. So what I mean by that is do 7 minus 4 plus 3 minus 1 plus 2. So 7 minus 4 is 3, plus 3 is 6, minus 1 is 5, plus 2 is 7. And when you're all done with that, that's your remainder. So to recap, start with your number on the left, on the right, and keep in mind, this only works when dividing by 11. Start with the number on the right, and then alternate between subtracting and adding. So we have 7 minus 4 is 3, plus 3 is 6, minus 1 is 5, plus 2 is 7. Okay, now for number 8, we have 961,854. Now you might notice that we can group these into multiples of 6. So for example, 96 is a multiple of 6, 18 is a multiple of 6, and 54 is a multiple of 6. So when that happens, well, let's just start off like normal and see if we can find any patterns. 6 goes into 96 16 times. Or if you didn't have that memorized, 6 goes into 9 one time with a remainder of 3. And then drop down the 6, we have 36. And then 6 goes into 36 6 times. Okay, now 6 does not go into 1. Here, let me show this as long division so it's a little bit more clear. Should have just started off with this. So 6 goes into 9 once. Then you subtract that. 6 times 1 gives you 3. Bring down the 6. Then 6 goes into 36 6 times. Write the 36. Subtract it. That's 0. When you bring down the 1, 6 does not go into 1, so we end up with a 0. Then we bring down the 8. 6 goes into 18 3 times. Then once we do our 6 times 3, 18, subtract that. We get 0. Bring down our 5. 6 doesn't go into 5, so we have to write a 0. Bring down our 4. 6 does go into 54 9 times. And so our answer is 160309. So the effect of these zeros is that essentially you can just treat this as a bunch of mini division problems. So you can do 36 divided by 6, which gives you 16. Then 18 divided by 6, which gives you 03. Make sure to take up 2 decimal places, or 2 place values. And then 54 divided by 6 is 09. So to recap, whenever you have a string of numbers like this, and you're dividing it by a number that is a factor of all those. So like 96 is 16 times 6. 18 is 3 times 6. 54 is 9 times 6. Something like that, where you have multiples of what you're dividing by all stringed together. What you can do is, first you have to look at how many place values each of your multiples is taking up. So what I mean by that is this 96, that takes up 2 place values. That 18 also takes up 2 place values. That 54 also takes up 2 place values. And that's how we're going to know how many to take up in our answer. So 96 divided by 6, we know that's 16, take up 2 place values. 18 divided by 6, we know that's 3, make sure to take up 2 place values, so 0, 3. 54 divided by 6 is 9, 0, 9, make sure to take up 2 place values. So 961854 divided by 6 gives us 160309. Okay, second to last question, we're almost done. Number 9, we have 49 times 0.25. Now, what I would do is just convert our 0.25 into a fraction. So 49 times a fourth, which is also the same thing as 49 divided by 4. Well, I know 48 divided by 4 is 12, and if I know that, I can just take 12 and add my extra remainder. So I need to erase some of this. Have some room. I know it says decimal, and I'm dealing with fractions, but it's okay. So 49 divided by 4. 4 goes into 4 one time. 4 times 1 is 4. Just subtract that. 0. Sorry, 4 minus 4 is 0. Bring down the 9. 4 goes into 9 2 times. 4 times 2 is 8. 1. And so we have a remainder of 1. So 49 divided by 4 is 12 with a remainder of 1. Which is the same thing as 12 and 1/4. And so convert that to a decimal, and you get 12.25. If you're not familiar with how I turn this remainder into a fraction, imagine you had 49 little squares, and you needed to divide them into piles of 4. So what you would end up with is 12 piles 12 complete piles, and then with your remainder, you would have a leftover 1/4 of a pile, because you have 1 and you need 4 to make a whole pile. So that's how I converted the remainder into a fraction, 12 1/4. And then once I have 12 1/4, convert that to a decimal, because that's what it wants, and you get 12.25. Okay, for our final question, we have 273 multiplied by 2020. So if you're unfamiliar with number sense, you may be wondering what this little asterisk right here means. And basically what it means is that this is an estimation question. You have to be within plus or minus 5% of the actual answer. So you do not feel obligated to get this exact. All you need is an estimation. In using that, I'm going to just make a very simple rounding. I'm just going to round this very simply. I'm going to take this 273. Maybe I don't want to work in the answer blank. Here we go. I'm going to take this 273. That's going to stay the same. And then I'm going to round my 2020 to 2000. Now, you may be thinking that's a bit of a large estimation, and it kind of is, but if you consider how large our boundary is, plus or minus 5%, if I change what's being multiplied by 273 by 1, it's going to change my answer by 273, right? And so if I do that 20 times, here, let me just use my calculator real quick. It's going to change it by 5,460. So this is actually going to be 5,460 away from the real answer. But if you look at how large this number is about to be, this is about to be in like the hundreds of thousands. And so with our plus or minus 5% error, we'll be well within the range. So what I can do here is just do 273 times 2, and then multiply that by 1,000. Multiplying by 1,000 has the effect of just adding 3 zeros at the end of your answer. So I'm going to go ahead and write that in my answer blank. Then when I do 273 times 2, just working this like column multiplication, 2 times 3 is 6, 2 times 7 is 14. I have to write the 4, carry a 1, and then 2 times 2 is 4, adding my 1 is 5. And so 273 times 2 is 546. Write that in my answer blank, and I'm going to use 546,000 as my estimation of 273 multiplied by 2020. All right, so if you need me to, and that does it for the 2019-2020 Test 1, Problems 1 through 10. If you need me to clarify anything for you, leave a comment, and I'll get back to you as soon as I can. If you enjoyed this video and found it informative, leave a like, and if you really loved it, make sure to subscribe. I'll see you later.